Hi everyone. Today we're going to talk about the physical and chemical changes lab. So I'm going to go over each of the little mini experiments that we will be doing for this recording, and I'm going to pause after each one so that you have time to decide whether or not a physical or a chemical change has occurred. In addition, I'm going to be writing the chemical equations for any of the reactions that occur on the board, so that way you can kind of get a sense of what's going on an atomic level for each of these chemical changes. If you have any questions, please write them down, and after the video, send me your questions through the discussion board so that I can answer them and all of us can benefit. All right, I am back with my lab apron and goggles, and I am ready to go for our first experiment. So in the first experiment, it says that we are going to take toothpicks and break them. So let's take a look. So as you can see, I have my toothpicks here. They're actually coffee stirrers that I've cut in half. I have my toothpicks here. I'm just going to break them into smaller pieces. Don't quite need all of these. Okay, there you have it. Is that a physical change or a chemical change? Be sure to record your observations in the data table and decide what type of change you believe this is. Okay, for the next part, what we're going to do is we're going to transfer these small broken up toothpicks into this large test tube. Hopefully you can do that a little cleaner than I can. Next, we're going to practice lighting a Bunsen burner. So what I ask that students do is that they move the apparatus away from where they are lighting the Bunsen burner. So to light the Bunsen burner, you're going to turn the gas valve so that it's halfway on. You should hear gas coming out of the gas jet, and then you're going to use your striker off to the side to light the burner. After the burner is lit, you're going to adjust the gas flow at the valve so that you have a flame that's about 2 to 3 centimeters tall. At this point, you can slide your test tube containing the wood sample from earlier into the Bunsen burner flame. You can also adjust the flame further at this point. So if I wanted to heat it up faster, I could make my flame larger. Okay, I've turned off the light so that you can see this a little better. The one thing you'll notice is that the top has begun to smoke. The wood is becoming charred. At this point, the wood is mostly blackened. I am going to turn off the gas jet and allow the test tube to cool. At this point, the chemical reaction has stopped. So I'm going to be very careful here. I'm going to loosen my utility clamp. You can see the charred wood. I'm also going to pour out some of this sample onto here so you can see what it looks like. Be sure to allow the test tube to cool completely, and do not stick it in a test tube rack when the test tube is extremely hot. It will burn and damage the rack. Decide, did a physical change or a chemical change occur? This is our final product. For the next part of the lab, we are going to weigh out 1/2 gram of sodium chloride solid. So to do this, you'll need a balance. Turn on the balance and wait for the balance to read 0.00 grams. Once the balance is reading 0.00 grams, you can add your weigh boat to the balance. A weigh boat is a simple way of holding a substance for weighing before using it. We don't want to pour the substance directly onto the balance. So we're going to place our weigh boat on the balance, and we're going to hit the button on the left side of the balance that says 0, or sometimes it says tare, T-A-R-E. What that does is it sets the balance back to 0 and subtracts out the mass of the weigh boat. Now we're ready to add our 0.5 grams. Note, if you accidentally add too much, please discard of the excess in the trash. Do not take the sample from the weigh boat and return it to the bottle. You risk contaminating the entire bottle. Next, we are going to add our 0.5 grams of salt to our small test tube. So here I have a small test tube. It's currently in a test tube holder, and the weigh boat allows us to fold the boat and transfer the sample directly to the test tube. The next part of the experiment calls for us to add 2 milliliters of water. So I have pre-measured this in a graduated cylinder. I now have my salt and water together. To stir this, hold the test tube and tap gently on the bottom. Tapping gently will stir the solid into the solution. We are looking to dissolve all of the sodium chloride that we added. At this point, the sodium chloride we added has been dissolved. The solution appears just like it did before, because all of our ionic solid has now dissociated into sodium ions and chloride ions that are floating around in the solution. Is this a physical or a chemical change? Okay, the next step calls for us to heat our sample. We are now ready to heat our sample. In order to do this, we're going to use a Bunsen burner, a ring stand, an iron ring. So I'll attach that to the ring stand. You want it about 5 centimeters above where the top of the gas jet is. On top of that, we're going to put a clay triangle. That's going to hold our crucible. So a crucible is like a cup. It could be made of ceramic, or it could be made of metal like this one is. So we're going to sit the crucible in the clay triangle, and then we can transfer our sodium chloride solution that we just mixed up into our crucible. When we're heating the crucible, we want to make sure to cover it with a lid, but don't cover it completely, because that will prevent the water that we're trying to drive off from escaping. So instead, place the crucible lid on the crucible ajar, allowing a small space for the evaporated water to escape. When you're ready to begin heating, first you must light up your Bunsen burner. So again, remove the Bunsen burner from underneath the setup. Turn on your gas. Light your flame. Adjust your flame so that it's about 2 to 3 centimeters high, and then you can place your flame underneath the crucible and begin heating your sample. Since there's such a small amount of water, you'll quickly hear the water start to boil. Now, and it's probably difficult to see, you can start to see some of the water vapor from the sample evaporating and leaving the crucible. When all of the water vapor has evaporated, turn off the gas jet and allow the crucible to cool before handling. use a pair of crucible tongs to transfer the lid and the crucible to the base of the ring stand to allow for it to completely cool. The inside of the crucible now has our dried sodium chloride. All of the water has been evaporated, and we've recovered the sodium chloride, and that is now coating the interior of our crucible. Is that a chemical or a physical change? You are now looking at a top view of the crucible. In the next step, we're going to add water and redissolve the sodium chloride solution. I'm using a glass stirring rod to get the pieces of sodium chloride that had adhered to the side. At this point, we have our sodium chloride solution back. In our next step, we are going to add a few drops of silver nitrate. Adding silver nitrate causes a white precipitate to form. So you can better see what happens when a precipitate forms, I'm going to repeat that step. This time, my sodium chloride solution has been transferred to a test tube, and once again, I will add silver nitrate to the top so that you can see what precipitation formation looks like. Notice the white solid that has formed at the top of the test tube. If I mix the test tube, the rest of the solution will begin to precipitate as well. If I allow the test tube to rest undisturbed, the solid that forms as a result of a chemical reaction will settle to the bottom. We're now looking at our solution, our original solution, back in the crucible. I've placed it back on top of the iron ring and clay triangle, and again, the lid is ajar. We're going to once again heat this sample up to drive off any water. Be sure to leave an opening between the crucible lid and crucible, which will allow the evaporated water to escape. When the sample is finished heating, carefully remove the crucible lid and the crucible. Allow it to cool on the base of the ring stand. You are now looking at a top-down view of the crucible. Inside, you can see the silver chloride solid recovered. Is this a physical or chemical change? At this point, our precipitate has cooled sufficiently. I am now ready to add the 15 milliliters of ammonia. You can stir this using a glass stirring rod. I'm going to transfer this solution to a test tube so that you can see. So if you notice, the solution is somewhat clear. There is no precipitate left. The addition of ammonia dissolved the precipitate and formed a complex ion. Is this a chemical or physical change? For our next experiment, we have some copper chloride solution, approximately 20 milliliters of it, and a small aluminum foil ball. We're going to carefully add our aluminum foil ball to the copper chloride solution. Closely observe what happens. If you look closely, you will notice small bubbles forming on the bottom of the aluminum foil where it's in contact with the copper 2 chloride solution. You will also notice a brown precipitate forming. If I tap the aluminum foil, you'll notice I can get some of those brown flakes to fall off to the bottom. Is this a chemical or a physical change? What do we think those brown flakes that formed are? In our next experiment, we are going to be adding some cupric sulfate pentahydrate, also known as copper 2 sulfate pentahydrate, to a crucible and heating it. So first I'm going to add some of the solid to the crucible. And now I'm going to heat it using the Bunsen burner as I did earlier. Notice this time, because we are not heating a liquid, we don't have to worry about covering the top. In fact, we want to leave it uncovered so that you can observe the reaction. You will notice the sample is beginning to become white. So the copper sulfate pentahydrate sample, which was initially blue, is slowly turning into a white powder. At this point, I can turn my Bunsen burner off and allow the sample to cool. Was this change a physical change or a chemical change? Okay, our sample of copper 2 sulfate pentahydrate, which we evaporated, has now cooled. Okay, we are back. Our sample has now cooled sufficiently. For our next step, we will rehydrate the sample by adding some water. Pay attention to the change. Notice the white powder has now changed into a blue solution. Just going to mix this up. Okay, our sample has now dissolved. I'm going to add a limited number of drops of ammonia. Notice the change. I'm now going to add an excess of ammonia. Notice the change. I'm now going to repeat this process by first transferring the copper sulfate anhydrous, so without water, the anhydrous powder to a test tube. This will allow you to see the changes more easily. So I have my dried sample. I'm going to first add water, just as I did in the crucible. Going to mix this up so all of our powder dissolves. So here is our sample. Is that a chemical or a physical change when I add water to the dried sample? It's tricky. I'm now going to add a limited amount of ammonia to our sample. Notice the sample becomes cloudy. I'm now going to add an excess of ammonia to our sample. Notice, even though the sample has changed color once again, it is now transparent. In our last experiment, I have weighed out a sample of sodium bicarbonate. I am now going to add the acetic acid solution to the sodium bicarbonate. Is this a physical change or a chemical change?